Hey science ninjas, this lab is gonna be sweet! Yeah. Oh, how old is that? Today what we're going to do is the sugar experiment. The sugar experiment is really 3 mini experiments wrapped up into one, and what we're going to do is practice with the different types of variables. So if you remember from class, right, there are the independent variables. The independent variables are the things that you as a scientist get to manipulate. They're the things that you get to control, right? So if you're setting up an experiment, you get to pick how many subjects are going to be in it, or what time of day it's going to be in, or what they're going to be subjected to, or things like that. And the dependent variable, that's the type of variable with what responds or what happens inside of the experiment. So maybe 5 people fall asleep during the experiment, or maybe this thing is preferred over that thing when you're judging things or things like that. So what we're going to do is the sugar experiment today to practice with this and everything. So we want to keep all the variables the same during each one of the experiments, except for just one thing, right? And that makes a good controlled experiment, meaning only one thing is being changed at a time during the experiment. So normally you'd have your lab books, but for now you're just kind of watching, and instead of doing the lab books, there's going to be a short quiz that we'll have for you. So the hypothesis is, what we're going to try to do is we're going to take 2 sugar cubes for each one of the experiments, and we're going to keep everything the same except for one thing that we're changing in this experiment. So what we're going to do is we're going to try to see for each one of the 3 experiments how they dissolve in water. So what we need is, we need 10 milliliters. We need at least 10 milliliters of water in each one of these test tubes that we have right here. So for filming purposes, let me get 10 milliliters of water. There we go, 10 milliliters, and we'll put it into one test tube right here. We'll get 10 milliliters of water. Again, these are variables that we're keeping exactly the same amount in there. So we have 2 test tubes with the same amount of water inside of them. What we're going to do, let me see if I can show you here, is we're going to put 1 sugar cube in this test tube, 1 sugar cube in that test tube, and what I'm going to do is I'm going to stir just one of these test tubes, all right? And I'm going to stir it for a little bit of time here, about 3 minutes. I'm going to keep stirring. While I'm doing this, maybe you can already tell. What do you think what is your hypothesis going to be, right? Which one of the 2 sugar cubes is going to dissolve the most? All right, I think that's going to be enough stirring for right now and everything. Now, our goal was to see which one of the 2 sugar cubes dissolved the fastest. And I think you can see from our results right here that definitely the one that was stirred, the one where the water was agitated, well, the sugar cube is almost completely dissolved. I could just see a couple little tiny particles of sugar left in there. While as the one that was not agitated or not stirred, well, sure, I mean, there's still a big lump of sugar in there and everything. So the conclusion is definitely stirring definitely helped to dissolve the sugar faster, right? So that could be our conclusion for our first experiment. It's time for experiment number 2 in our sugar cube experiment extravaganza. So for this one, we have all the same things, same sugar cube, same room, same 2 test tubes, same water. And what we want to do is, yet again, we want to fill the 2 test tubes. Oh, I got a little extra. Oh, now there's not enough, of course. There we go. Okay, there we go. We want to fill up the test tubes with 10 milliliters of water. Exactly, just like before. So 10 milliliters right there. Yep, 10 milliliters right over here. And again, we want to see which one of the 2 sugar cubes, we'll pick on these 2 little guys right here, which one of these two sugar cubes can dissolve or will dissolve the fastest for it. Now, the thing that we're going to change, the only one variable that we're going to change, everything else is exactly the same. Same test tubes, same temperature water, same size rack, same area. I mean, everything's going to be the same except for, oh, and let me pick on this sugar cube. Yeah, no, let me pick on two sugar cubes. There we go, that are exactly the same. There we go, that are exactly the same size. Same size sugar cubes and everything. The one thing we're going to change this time is surface area. So this little sugar cube right here is going to go in this test tube right here. This little sugar cube is going to go in that test tube, but we're going to introduce the hammer to one of these. So this poor little guy right here, we're going to put him in the piece of paper and, sorry. Look, a couple little pieces shot at, oh, there we go, okay. There we go, okay, so now we've got, again, two sugar cubes of equal size and everything like that. It's just that one is whole and, well, one has been kind of ground up and everything a little bit. So, here's what we can do. We can put this sugar cube in here. We'll put this sugar cube down in here. And if we give them each a little stir right here, we'll see what happens. Which one do you think is going to be the one that's dissolved the most? Well, if you're looking at it, you can definitely tell the one that's, being agitated. Well, they're both being agitated, I guess we should say here, right? But as they kind of stir up here and everything, well, definitely one's dissolving much, much more than the other one as they kind of keep stirring here and everything. So they're both getting all the same variables, except for the one thing, the one variable that we changed, right? The one manipulated variable, or the one, independent variable, because we changed it and everything. So you can see, definitely, the one that was a full sugar cube is not dissolving very fast at all. The one that was ground up, the one that had more surface area, is certainly dissolved. I mean, it's almost completely dissolved away. If we kept stirring for a little while, it would be completely gone. So that's experiment number 2, right? Surface area definitely matters as a type of variable for us. Experiment number 3 for our sugar cube experiments that we have. Now, the one variable, the only thing that we're going to be changing in this experiment is going to be the temperature of the water. I've got one beaker of water right here that is literally ice cold. I've got another one over here that just a few moments ago was boiling, so it's really, really hot. So let's kind of get this going because this is time sensitive. Yet again, oh, there we go. We're going to get, yep, perfect, 10 milliliters of water on this side. I have to be careful with this one. 10 milliliters of water over on the other side. Careful, careful, don't burn yourself. No, a little more. Oh, there we go, perfect, perfect. 10 milliliters on this side. Let's take 2 equally sized, sugar cubes right here, plop them in, and see what happens, right? So if we kind of agitate them for a little while, what do you think? What's your hypothesis? Is the warm water one going to dissolve faster, or is the cold water one going to dissolve faster? Cold on this side, warm on this side. What do you think is going to happen? Oh, I can see it already. Look, already. The warm water one is definitely dissolving faster than the cold water one. I think we have our winner already right here. Oh yeah, look, there's only a tiny little nub left on the hot water side, and the cold water one is definitely slower it's actually slower than normal even and everything, right? And the reason for that is the speed of the molecules, right? Because this one's full of hot water, the water molecules literally are moving around. I mean, they're microscopically small, but they're moving around tremendously fast compared to the water molecules on this side. Because they're so cold, they're moving around much slower. So that means literally less water molecules as they move around are bumping into the sugar cube over here, where what used to be the sugar cube over on this side, I mean, they were bumping around like crazy, smashing into that thing, and they hit it so much, it literally dissolved it away, right? That's kind of like, do you ever put your hand in hot water and it hurts? It literally hurts. And did you ever wonder why hot water hurts you? I would not want to put my hand in boiling hot water right now. It's because the water molecules inside of here are moving so fast that, just trillions of them hitting your skin, it's hurting. It's like a trillion little tiny hammers knocking on your skin and everything like that. Enough that it can seriously damage you. I mean, it could literally, cause a lot of pain and everything. So that's our final conclusion for the experiment right here is, well, hot water definitely dissolves faster than the cold water test. So this concludes our variable experiment practice that we had with sugar cubes. These, right? We tested, the temperature of the water. We tested stirring or not stirring. We tested surface area by grinding them up. Thanks for joining me for our sweet experiment that we did. This is the most tasty experiment of the entire year, even though we never get to taste any of it. Remember the different types of variables that we work with. First, we work with the independent variables. These are the variables that you, as the crazy mad scientist, get to control, right? So we got to pick what we were doing for it. We did 3 different experiments with 3 independent variables. We tested first, stirring them or not stirring them. Second, we tested were they crushed or not crushed? We changed the amount of surface area. In the third experiment, we tested temperature, right? Hot water compared to cold water. Those were our independent variables. The manipulated variables, or the dependent variables, right? These are the responding variables. This is what happens in the experiments, right? And so for each one of the experiments, we were trying to see, did the sugar cube dissolve quickly or really slowly for each one of the different experiments that we did for us. Then the last type is the control variables, right? Control variables are the things that we kept the same, other than the one individual thing we were changing for each experiment. So we didn't change, for example, we didn't change the amount of water for any of the experiments. We didn't change the type of vessel that they were in. We didn't change, the temperature of the room or all kinds of other crazy things that we could have changed. Instead, for each of the experiments, we tried to keep everything exactly the same, except for the one variable that we were changing. All right, remember, do science always.